not 2.
Yeah, it is. The
One
answer's
by 5.
The answer's totally 2.
No, the answer's clearly.
Yeah, the answer's -7.
Why do you guys say
Wait, can we have more time?
Listen, what are you talking about? This is
Sorry.
I got 4 questions. Carly. Then what are you talking about? Okay.
No, because you guys don't sit there.
I got it twice before I need 5.
Okay, good afternoon, ladies and gentlemen. So for some of you that was a good warm-up to get your minds in the right frame. So before, rather than reveal answer and talk about how, let's talk about some things that we can figure out. And I did give you a hint about what the actual belt was. Of course, you had to know what I was talking about when I referred to the belt. And so basically what it comes down to is the fact that the belt does not touch this part of the circle, and the belt does not touch this part of this circle. So you have to figure out what is the distance going around from here to here. What is the distance from here to here? What is this distance around to here? And what is the distance from here to here? Let me put it a different way. And I've used this technique with you since last year. Simplify the problem. If I had just asked you to give me, to give me, if we drew this line in right here, if I drew this line in right here, and I asked you to use the clues in the rest of the picture to just give me the measure of this arc, you should have actually had no problem whatsoever. So you do need some clues from here and from here. You do need some of the clues. But if all I asked you to do was get me this arc, there shouldn't have been an issue. And then finding this arc really wouldn't be that much of a stretch from this one because it's really the same thing. So then it's just a matter of figuring out what's going on here with these lines. And that actually ends up being pretty basic as well. You just connect this one line. So let's add in a few details. Could someone tell me the angle measurement that's right here? What is that angle? Jada? You said that with a question mark after it. It is 90. Could someone explain why? Why is that a 90-degree angle? Alicia?
when like a tangent line and the radius, like where they meet, there's always a 90 degree.
Exactly, and that was said very well. A radius and a tangent will always form a 90-degree angle. And so now, if you have a 90-degree angle here and here, and we can now see that these lines must be parallel, that means that this must be a 90-degree angle as well. Can someone tell me the distance of this red line here? What is the distance of that red line? Michaela?
3 inches.
That is 3 inches. So could someone tell us, what is this shape right here? What is that shape right there? Brandon? That's a square. So if that's 3 and that's 3, then that must be 3 and that must be 3. So we already covered that you should be able to find me the arc length going around from there to there. And now you know that that's 3 to there and that's 3 to there. So if all I asked you for was the distance from here going around back to there, you should have been able to do it. And then all I asked you to do was do that twice. So it certainly was not an easy question by any stretch. It was not easy at all. One of the issues I saw with this group in particular was that some of you gave up before you started. And I don't think you really gave up, but I think you convinced yourself that it was too hard. And you operated from that standpoint. If you operate from the standpoint that this is going to be too hard, then of course you're going to fail. Because you convinced yourself you were going to. That's just for a few of you. Many of you persevered and really tried, but it was hard for you to see. That's why I keep encouraging you to eliminate part of the picture, or take one picture and separate it into two pictures. Let me put it a little more harshly. If I said that whether or not you get to sit in my class on Monday is based on whether or not you solve this problem today, there would be a little more urgency and a little more focus and a little more positive attitude towards solving the problem. The one hiccup that came from me was that I didn't have enough time to devote to the question. Had this been third block, we would have spent much more time on it, and I would have let you wrestle with it for a longer period of time, but I just don't have the time to devote. So, comments and questions before I reveal the answer? Okay, so I am going to reveal the answer for this one. It comes out to approximately 26.85. If anywhere around 26.8, 0.9 would be acceptable. So, again, I don't have any time to really devote to it, so I'll try to find another day when maybe we finish early or something to come back to this question. So, today we're going to talk about area compared with yesterday when we spoke about circumference. And today we're going to talk about sectors, which is new, compared with arc length yesterday. What you're going to see is a lot of parallels between today and yesterday. So our goals by the end of today are to be able to find the area of sectors and to find arc lengths, which you already know how to do, but how to have that incorporated. And new terminology is going to be, sector. So, first of all, what is a sector? This is new for us. A sector is a part of a circle that is bound by two radii and its intercepted arc. You name a sector by using the three letters, the two endpoints of the arc, and the center of the circle. So this would be sector ACB. And so what you're going to see today is a connection between the arc measure, the arc length, this angle, the circumference, and then the area of the whole circle. So, any questions about what a sector is? Go ahead.
How do you write out a sector?
You just have to write sector. There's no shortcut for it as far as I know yet. I'll keep looking. So that leads us to the big idea of the day, which is the relationship between the area of a sector, the area of the circle, and the measure of the arc, and the number of degrees in a circle. Let me give a warning. I was advised for this lesson to spend a little time on area of a circle. I decided not to. I did not feel that there was any reason to. Hopefully you already know how to find the area of a circle, or at the very least, I show you the formula and you can do it. I don't think it's that big a deal. So we're going to operate as if you already know how to find the area of a circle. The area of a circle is pi r squared. So when we talk about area, we're talking about the space inside the circle. Circumference is the distance around the circle. So the relationship, the ratio of the area of the sector to the whole area is actually the same ratio that we saw yesterday, which is the ratio of the measure of the arc to 360 degrees. And so we can use that fact to solve problems. You probably have questions or just curious about things, but just try to let it go until we go through some different scenarios, and then if you still have questions, of course, feel free to ask. So, Let's jump in. Finding the area of a sector. So we are going to start out with basics today, and then we will quickly move to more complex. And I'm also going to introduce one other new idea. It's a small idea. So find the area of the sector, but we're going to give our answer in two different ways. We're going to give our answer in terms of pi and rounded to the nearest hundredth. So I want to explain what this means in terms of pi. So you're going to start seeing that a lot. You're going to see that this year, you're going to see it a lot next year and beyond. So let's talk about pi. And I want to pause on the actual question first, for a moment. Pi is a Greek letter that represents a specific number. So we use letters in algebra and geometry to represent variables, things that change. Pi doesn't change. But we use a letter for it because the number goes on and on forever, and it's such a special number. It's so unique. So because we have it represented by a letter, it has some of the properties of a variable. But because it's a number, it also has the properties of a number. So for example, and I'll write right here on my board, just like 2x plus 3x is what? As a chorus, go ahead. Good. What would 2 pi plus 3 pi be? 5 pi. So it operates with the same properties that a letter does. The only difference is if I wanted to at the end, after I found 5 pi, I could then do 5 times and hit the pi button on the calculator and get an actual number. So what you're going to be asked a few times today is to express your answer in terms of pi. That means leave the letter. And round to the nearest hundredth, which means now convert it to a number. So let's go ahead and do that. So now take that idea and pair it with the big concept of the day, finding the area of this sector. So everything is based on the relationship between the arc measure and 360 degrees. So the arc measure in this case is 131 out of 360 degrees. That ratio is going to equal the area of the sector which is JGH, to the area of the whole circle. So we can now find the area of the circle. The radius is 12. This m is meters. So the radius is 12 meters. The formula for the area of a circle is pi r squared. Square this number, multiplied by pi. But we're going to leave the pi. So that's really easy. That's mental math. What's 12 squared?
144.
144. So 144 pi is the area of this circle. Now solve the proportion for the area of the sector. Leave the pi there. So my calculator up here doesn't really do this well, so I'm going to have to join you with one of these. So you don't need to put the pi in the calculator. You know that eventually we're going to put pi back in. So you can just do 144 times 131. That's going to be the cross product here. And then divide it by 360. Divide 360. And now we know we have to tack the pi symbol onto the end of that. So the area of the sector JGH is 52.4 pi. That's leaving something in terms of pi. Now, with that number in your calculator, push times and push the pi button. And then hit the equal sign. And now you have the exact answer. And you can round it to the nearest hundredth because that's what we're asked to do. So the area of sector JGH will be approximately equal to what? Just one person got in the calculator? Oh, a whole bunch of people. Brandon?
164.62.
Yeah. 164.62. And this is all in square meters. So we've got meters squared, meters squared. So that is finding the area of a sector and leaving answers in terms of pi. Any questions or comments on how we did that? Dalton?
You can't just put meters.
I'm sorry?
You can't just put meters.
No. Area is measured in squares. It is not linear. It's not a straight line. It's space. So it's all squares when you talk about area. Even if it's a round space, you're still talking about squares. Any questions? Any concerns? Any observations? Good. Checkpoint number 1. Find me 3 different measurements. I would like the answers in terms of pi, and then I would like the answers rounded to the nearest hundredth. I would like the area of circle D, I would like the area of the red sector, and I would like the area of the blue sector. You got 3 questions, you got 3 minutes. Let's see how we did. First person I call on is going to give me the answer in terms of pi. Second person is going to give me the answer rounded to the hundredths. So part A only, the area of circle D. I've got student number 5 and then student number 17. Student number 5, what is it in terms of pi? 196 pi. Very good. And student 17, what is it as a decimal? Approximately 615.75 square feet. Very good. What about the area of the red sector? First, give me it in terms of pi. I've got student 18, and then student 21 will give me the decimals. Student 18. Okay, student 21, what is it as a decimal? So, if you're going to be using pi, I'm sorry, I should have revealed that before. If you're going to be using pi, then you want to be as precise as possible. Then you don't want to put 65.33 because that's an approximation. It's 65 1/3 pi is approximately equal to 205.25. Don't mark it wrong. You did a wonderful job. But in the future, try to think about things like that. And what about the area of the blue sector? We've got student 11 in terms of pi and then student 13 as a decimal.
130.67.
Okay? Student 13? 410.5 square feet. So let's talk about approach. How did you find the area of the blue sector? How'd you do that? Daniela and then Alicia. Okay, so you used 240, and how'd you get the 240? Very good, so you knew that this angle was 240 degrees. Alicia, did you do the same thing? Anyone do anything different? Brandon, what'd you do?
I subtracted 205 from 205.25 from 650.
Yeah, so there's a little bit of a shortcut because we only have two sectors. They add together to the area of the whole thing. So if you have one of them, you could subtract the area from 360, from the overall area to get the other. So either approach works very well and you clearly get the same answer. Another way to say it, if we add this plus this, we should get that. Anyone have any comments or questions about how we went about this? Any concerns, any observations, any thoughts? Absolutely. If you add 130 2/3 plus 65 1/3, you get 196. Absolutely. Very good point. Any other comments, questions? We're going right into checkpoint number 2, and this is a real-world application of this idea. So read, use the picture to help yourself. You got 3 minutes. real world application probably makes more sense to have a number, but it kind of depends. All right, so let's see how we did with applying this to a real world scenario. So for checkpoint number 2, just give me your answer. I got students 12, 15, and 6. Student number 12.
345 inches square.
Okay, student number 15. Student number 6. So the correct answer is approximately 345 square inches. And the question is actually not that big a deal. It's the scenario that you have to interpret that makes it a little bit of a challenge. But what you have to understand is that even though there's no circle here, it's based on a circle. So we're talking about a windshield wiper that's going like this. So I'm asking you, what is the area of that sector formed by the motion of the windshield wiper? That's what I was asking. I know my picture's not perfect, but that's what's happening here. This windshield wiper is forming an arc and a sector by its motion. So we are told that this is 122 degrees. And we are also told that the windshield wiper is 18 inches long, which is the radius of this circle. So here's something that we just now found out. That even if there is no circle, if something is moving in an arc motion, there is a circle that it's based on. And you have to be able to see that circle. Okay? So are there any questions or observations about this? Anything at all? All right, so let's take this next level. And let's find areas of complex shape. So the shaded area is going to be painted. Paint is based on area. Anytime you have to paint, whether it's a rectangular wall like the walls of my classroom or some unusual shape. This is going to be painted, so you need to know the area of it. So we're given some measurements. So what I would like you to discuss with your team in a 1-minute team talk is not the answer. And I don't even want you to execute your plan, but I would like you to develop a plan of attack. what process or what sequence or what chain of logic can we follow to try and find the area of that shaded region? So you got a 1-minute team talk, and then we will come back as a whole group and share out our plan that we developed. Go.
Find the area of the rectangle and then subtract the area of the arc from
Find the area. Oh, the shaded
Oh, and then you have to see like
You don't even need to do that. You already know this. That's not why. There's another simple reason why. All right. What's our plan of attack? What'd you come up with? Plan of attack. We'll start with Davis, and then we'll go to Alicia.
First you would find the area of the circle part, the sector. Then you would find the area of the isosceles triangle. Then you would take that area and subtract it from the sector. And then you would take what was left over and then subtract that after you find the area of the rectangle. Subtract what was left from the sector by that, and then you get the area of the arc.
Okay. Alicia, what did you guys come up with?
We're going to use the equation to, we're going to use the 90 degrees as the measure of the angle because that's a right angle.
Right.
And then the 4 feet is the radius, and then
Okay. Well, I must say that Davis really articulated it incredibly well, and Alicia, it sounds like you guys sort of agree. But I'm very impressed, Davis. And it took me a while personally to figure that out. But yeah, what we need part of this rectangle up here. So we need to subtract this little circular part. But we don't know how to find the area of just that. But we do know how to find the area of this whole thing. But as he said very, very astutely, this triangle is actually not part of it. So we can find the area of this, subtract the area of this, and then we'll be left with this white area up here. Then we subtract that white area from the rectangular area, and we've got the gray area. So let's go ahead and start. Let's put the plan into action. Let's find the area of the sector. Remember that this sector, even though there's no circle here, there is. You have to imagine the circle going all the way around. And we are told that it's 90 degrees. So we know that, 90 out of 360 will equal the area of the arc out of the area of the circle. And even though the circle's not there, it is. And the area of the circle is going to be the radius squared times pi. So the radius squared is 16. How about we leave it in terms of pi and see if that maybe helps us work through things. 16 pi. So now find the area, I'm sorry, the area of the whole sector. Go. Give me a thumbs up when you got it. Yeah, keep it in terms of pi. We can always change that. Okay, we got over there, we've got it. Over here, we've got it. Okay, Kayla, what did you end up with? Yeah. I'm sorry? Okay. In terms of pi, what do you get, Maria?
4 pi.
Yeah, it's just 4 pi. So the area of this whole sector is 4 pi. But we don't want the whole thing. We want just this part up here. So we need to subtract out from that triangle. How can we find the area of that triangle? Got a few different ideas? Okay, Kayla, go ahead. Good. Area of a triangle is base times height divided by 2. But what's the base, what's the height? Yeah, that's right. So this is a circle, which means this is a radius as well. But we couldn't possibly say that that's definitely the base and the height. My initial instinct was to draw a dotted line here and try and figure out the height that way, and then this base is going to be 5.7. But could someone tell us why we can just simply do 4 times 4 divided by 2? Oops. Why can we do 4 times 4 divided by 2? Chris?
It's 45 triangle.
Yeah, this is a 90-degree angle right here. How do you know?
Because since the arc opposite from is 90 degrees and the angle is at the center, that means it would be a 90 degree angle.
Exactly. The arc measure is the same as its central angle. That's a 90-degree angle. This is a right triangle. For a right triangle, the base is one leg and the height is the other. So the area of this is going to be 4 times 4 divided by 2. That's mental math. The area of this is 8 square feet. So now we know that the area of this is going to be 4 pi minus 8 square feet. And this is also in square feet. So leaving it in terms of pi didn't really help us. Not this time. So we need to do 4 times pi and then subtract 8 from it. So luckily we've got one of these magic things. 4 times pi minus 8. And so the area of this, and I guess I could color code this, the area of this region is what? Dalton? Yeah, it's approximately 4.57. Square feet. So now if we take Dalton's approach from his team, got one last step. Find the area of the whole rectangle and subtract the 4.57 square feet, and we get the area left over. Danielle? Comes out to approximately 9.83. So let's do it quickly. We got 5.7 times 1.5, and then we're going to subtract 4.57. So what did you get, Daniel? Can't be 9 point something. This doesn't even come out to over 9. Something went wrong. What is it? Oh, yeah. Comes out to 3.98 square feet. comments, questions on how we approach this? Any concerns? Well, I did have a team challenge, but because of time constraints, we're not going to be able to do it. But this was what I was going to task you with, finding the area of the shaded region. And it's an excellent team challenge, and it worked out really well. We'll have to explore it on a different day. Your homework is page 722, numbers 11 through 16, 26 to 32, and 37. It works out to 14 points.